In this lesson, we'll cover the features and valuation of stock, both common and preferred. Common stock represents ownership. It's an equity position. In finance, we assume shareholders are active owners. Stockholders elect the board of directors who hire top management, who in turn hire down the ladder. Management is acting as agents for the owners, and as such, their goals should be to maximize shareholder wealth, meaning maximize the stock price. Common stock can, but is not required to pay dividends. They are not a liability of the firm as interest on bonds is. Each quarter, the board of directors meets and votes whether or not to pay a dividend and how much to pay. Dividends are not tax-deductible to the firm, and they are ordinary income to stockholders. If a corporation owns a non-controlling interest in another firm, then 70% of dividends received from that ownership are tax-exempt. Thus, many firms own preferred stock in other firms. Remember this chart from Chapter 1? Outside investors, corporate insiders, and analysts have different information and use a variety of approaches to estimate a stock's intrinsic value. In equilibrium, we assume that a stock's price equals its intrinsic value. Outsiders estimate intrinsic value to help determine which stocks are attractive to buy or sell. Stocks with a price below its intrinsic value are undervalued. Those with prices above their intrinsic value are overvalued. There are three techniques to value common stock that we'll cover in this lesson: the discounted dividend model, the corporate valuation model, and the PE multiple approach. We started our valuation of capital assets with bonds in Chapter 7, since bonds are much easier to value than stock. Recall that the value of a financial asset is the present value of its future expected cash flows discounted at an appropriate rate. With a bond, at the time it's issued, we know exactly what each payment will be, and we know when it will be paid. We know exactly how long the bond will be outstanding and exactly what we'll receive at maturity. Contrast that with common stock, which has an infinite life. We don't know when we'll sell it nor what we'll sell it for. We don't know if it will pay dividends or how much they will be. Definitely a bigger challenge. So technically, the value of a share of stock is the present value of all its future dividends, to infinity. The fact that common stock has an infinite life means there's no closed-form solution to the valuation model. So we have to make some simplifying assumptions to come to a valuation method. If we assume that a firm's dividend grows at a constant rate forever, using a Taylor expansion and a lot of math, the infinite valuation model can converge to the constant growth, or the Gordon growth model. Note that D0 is the dividend just paid, so it's known, it's history. RS is the required return on the stock, and G is the constant growth rate. Be careful as to whether a problem gives you D0, the dividend just paid, or D1, the next expected dividend. So what happens if the growth rate is larger than the required return? Well, the formula will return a negative stock price, which is not feasible. So the constant growth model requires that the required return is greater than the constant growth rate. The dividend is expected to grow at a constant rate forever. Let's look at each component of the equation. D0 is the dividend just paid. D1 is the next expected dividend. By definition, it's D0 times 1 plus G. G is the constant growth rate, and RS is the required return on the stock. So where do we get that? CAPM, Chapter 8. If we're given a risk-free rate of 3%, a return on the market of 8%, and a beta of 1.2, we can find the required return on this stock, 9%. With D0 equal to $2 and growth equal to 4%, our required return of 9%, we can set up our example on a timeline. If D0 is equal to $2 and we have a constant growth rate of 4%, then D1 is equal to D0 times 1.04. D2 is equal to D1 times 1.04. Discounting each expected cash flow back to time zero. Note that the exponent of each denominator, n in your calculator, is the period in which the cash flow occurs. So D1 discounted back to time zero is $2.08 divided by 1.09. D2 discounted back is 2.1632 divided by 1.09 squared, etc. Using the constant growth model, we only need D1, G, and RS to find the price at time zero, now, to be $41.60. Let's step back and look at our constant growth formula on the top. We are usually solving for the price today, P0. But given D0 and a constant G, we can find the price at any time in the future. P sub T is equal to D, T plus 1, divided by R minus G. Suppose we want to find the expected price of our stock 1 year from now. 2 ways to find it. Solve for D2, which we did, 2.1632, and divide by R minus G. Or, if the dividend is growing at a constant rate of G, then the stock price is also growing at the same rate. The stock price at time 1 is the price at time 0 times 1 plus G. As shown on the slide, same price. An asset can only generate return in 2 ways, cash income or price appreciation. For our stock with a 9% required return, dividend yield is the cash return, equal to D1 divided by P0. $2.08 divided by 41.60, 5%. Capital gains is the price appreciation, which is equal to G, 4%. 9% is equal to 5 plus 4. They have to add up to equal the required return. What if the growth rate is 0? Then the G drops out of the numerator and denominator, and we're left with the constant dividend divided by the required return, which happens to be the formula for preferred stock. As long as dividend growth can be reasonably assumed to be constant forever, finding the value of a share of stock is fairly easy. But what if the stock is growing at a supernormal rate for a few years before settling into a stable growth pattern? We obviously can't use the constant growth model, at least not for the non-normal years, but at some point the growth does become constant. Let's assume our stock is going to grow at 30% for year 1, 20% for year 2, 10% in year 3, and then stabilize at 4% forever. Required return still 9%. The timeline chart lays out the solution technique. Put the growth rates and the required return on the timeline. Calculate the non-constant dividends and the first constant dividend, D4. Use the first constant dividend to find the horizon value or the stock price at the end of the non-constant growth period. Horizon value is the first constant growth dividend divided by R minus G. Note that the horizon value here is P3 equal to D4 divided by R minus G, and it's discounted back 3 years. D4 is not used for anything else. Discount each non-constant dividend and the horizon value back to time 0. Sum them up, and that's the stock price. This method is followed step by step in the video tutorial posted with this lesson. So what does dividend yield and capital gains yield look like for a non-constant growth stock? They're calculated in the same way, but they're not constant. For the first year, dividend yield is going to be $2.60 over 62.78, 4.14. So capital gains yield is 9 minus 4.14, 4.86. Once the dividend begins to grow at a constant rate, dividend yield and capital gains yield stabilize. Dividend yield 5%, capital gains 4%, the constant growth rate. In this example, the dividend doesn't grow for 3 years, then begins growing at a constant rate. The solution technique is exactly the same. As with our other non-constant growth example, dividend yield and capital gains yield are found in the same way. During the non-constant 0 growth period, the capital gains yield does not equal the growth rate. Once the growth stabilizes, capital gains yield is equal to the growth rate, and dividend yield is equal to the required return minus capital gains yield. This video tutorial walks through a non-constant growth stock example, step by step, including using the TI Business Analyst 2 cash flow worksheet to find the stock value. Note that while the CF worksheet can ultimately be used, you must work out the timeline to find the values to use in the worksheet. Take the time to watch this video and make sure you understand and can find the current price of a non-constant growth stock. If the stock has a negative growth rate, does it still have value? Well, yes. Same example, but now the constant growth rate is a negative 6%. Be careful with the negatives, especially in the denominator of the formula. Capital gains and dividend yield, found in the same way, but since G is negative, the dividend yield makes up for it, being large enough to make the stock attractive. Our second valuation technique is called the corporate valuation model, or the free cash flow model, which values the entire firm, not one share of stock. Remember from our early chapters reviewing accounting, free cash flow is the after-tax operating income minus net capital investment. The formula is shown on the slide. Using the free cash flow model, we don't find a share price, we find the value of the firm in total. To find the value of a share of stock, we need to add the market value of the firm's non-operating assets, subtract the market value of debt and preferred, and divide by the resulting value of common equity by the number of shares outstanding. The free cash flow model is often preferred to the dividend model since it can be applied to firms that do not pay a dividend or to ones whose dividend is hard to forecast. The model does assume that at some point free cash flow will stabilize at a constant growth rate. So it can also be applied to firms whose free cash flow grows at a constant or non-constant rate. Where we found the value of a share of stock at the end of the non-constant period, in the free cash flow model, we'll find the horizon value, or the value of the firm at the end of the non-constant growth. Recall our basic valuation model for a share of stock and how, by assuming a constant growth rate, we could simplify to the constant dividend growth model. We can do the same for the free cash flow model. Note that when using free cash flow, we're discounting by the firm's weighted average cost of capital, which we don't cover until Chapter 10, so it'll be given. Using the same assumption of constant growth, we can simplify to a free cash flow version of the constant growth model. Let's walk through an example. Free cash flow for the past year, free cash flow 0, was $100 million. Be sure to pay attention to free cash flow 0 or free cash flow 1, the same caveat as with D0 and D1. The constant growth rate is 8%, cost of capital 12%. The market value of the firm's debt and preferred is $500 million, and the firm has 50 million shares outstanding. Using the free cash flow constant growth formula, we find the value of the firm is $2,700 million. Subtracting debt and preferred, the value of common equity, $2,200 million. Dividing by the 50 million shares results in a stock price, $44. With free cash flow, non-constant growth is frequently not a non-constant percentage, but rather estimates of free cash flow dollars. Other than being presented with dollars and rather than a growth rate, the technique is the same as with a non-constant growth stock. Here we find the value of the firm equal to $877.5. If the firm has $40 million in debt and preferred, 5 in non-operating assets, and 10 million shares, the value of common equity is equal to $877.5 plus 5 minus 40, equal to $842.50. Divide by 10 million shares, share price, $84.25. Our third method is the firm multiples method. This one's more of a benchmark, a back-of-the-envelope technique. Price earnings is the most commonly used multiple, with price to cash flow and price to sales sometimes used when firms don't have positive earnings. This method involves finding comparable firms and using their average P/E ratio against the study firm's earnings to estimate a share price. This technique is subject to serious estimation error depending on how well the comparables are chosen. We don't see preferred stock traded much anymore, but it's out there. Preferred is sort of a hybrid security. It's valued as a perpetuity since its dividend is constant. The dividend is fixed, more like bond interest. A preferred dividend can be skipped, but the firm cannot pay any common stock dividends until the preferred dividends are caught up, called a cumulative provision. Preferred is equity with an infinite life like common stock, but typically non-voting. Note that the formula for valuing a perpetuity is just the constant growth equation with G equals 0. In our example, a preferred stock pays a $5 annual dividend and is currently selling for $100. In this case, we turn the formula around to solve for the required return, 5%. This ends our coverage of stock and its valuation techniques.